Thought I'd provide you with a little bit of homework help. This is from lesson 2.6 and it's from page 130. A couple of problems. This is, as you can see, number 34. We have this parabola and it looks like it's a dilation of the parent y equals x squared. Dilation means that the size has been changed. It's either been made wider or skinnier, and in this case, as you can see, it has been made wider, because if I did plot the points representing the parent function, these are in twos, this would be 2, 4 and negative 2, 4. So you can see the parent is quite a bit skinnier than the blue graph that you're given in the book. So we could think of this as vertical compression. Alright, or I guess you wouldn't be wrong if you thought about it as horizontal stretch. But I'm just going to not use parentheses when I write this function being related here in the blue. So I'm going to refer to this as vertical compression, which causes the graph to widen or to become fatter than the parent. So the goal here is to find this missing number that goes in front of x squared that causes the compression, the vertical compression of the parent. And one other thing we know is, I'll just call this number a. This number a should be a fraction between 0 and 1, because that kind of coefficient in front of x squared will cause vertical compression. So the question becomes, how do I find this number that I'm calling a that will fill in this blank in front of x squared? Well, we just need a point off of the blue graph, this blue parabola. And one of the reasons why I wanted to do this one with you is because you may not have known for sure whether to call that point at 4, 3. But that is the point 4, 3. Now, if we can just take that point for x and y and plug into this quadratic function, and we'll just solve for a. Okay, so I'm going to plug 3 in for y, and we're going to try to find this number we're calling a, and we're going to plug 4 in for x. So we get 3 is 16a. And dividing by 16 on both sides, I get 3/16. So that gives me the answer for this coefficient for x squared, and gives me my final answer, 3/16. So my final answer is y equals 3/16 x squared. Okay, so if you can find a point, if the vertex is at the origin, it makes it kind of easy. Just find a point on your graph, substitute those numbers in for x and y, and you can solve for this missing coefficient. Okay, so let's take a look at number 37. We looked at translations. That's what this is. This is the parent parabola. Let me just show the parent in red. Probably getting used to seeing what it looks like. Okay, there's what the parent would look like, but this is a shift. We call it a translation of the parent 2 units to the right. Well, horizontal translations look like this. Sometimes I use the variable h or k, it really doesn't matter, but this number that sits in this spot tells me how the shift was made horizontally, and if it's a positive number, then I moved it to the right. If it's a negative number, then subtracting a negative would change this entire part inside the parentheses to plus, x plus something. Well, obviously we have shifted 2 to the right. That means the number that I'm going to substitute in for my h here is 2. So my answer for number 37 is this equation that represents the translation of the parent y equals x squared 2 places to the right. So once again, these horizontal translations can tend to be a little tricky. It looks like it should be left because of that being negative, but you literally have to focus on what this number is in this spot. Okay, and that will be your answer for number 37. So I hope that helps you out. If you have other questions, you're welcome to send me an email or come to academic support.